An abstract artist wishes to weld together metal rods to create a large rectangular object with a square base. So this is a square base. That means the length and width here of each side is the same. Let X represent the width of the base. So these are both the same. And the height has a length of Y. The artist has a total of 80 feet of metal rods to work with. So there are exactly 4 metal rods that each has a length of Y. So 4Y. And 1, 2, 3, 4, 5, 6, 7, 8. We have 8 lengths of X, and together that will add up to 80. Now it's asking us to isolate the height, or the Y. So I'm going to start by moving 8X to the opposite side by subtracting. Then I'm going to divide by 4. And then this 4 needs to be shared with both the left and the right. So Y equals 80 over 4 minus 8 over 4X. And when we reduce that, we get Y equals, 80 divided by 4 is 20, and 8 divided by 4 is 2. So now we have expressed the height of the object in terms of X. So volume is length times width times height. The volume of the object is length times height times width. So length times height times width. Let's do height last. Length times width is X times X. And now our height would be Y, but we're going to replace Y with 20 subtract 2X. Okay, algebraically to find the domain, I'm going to set each one of these equal to 0. So X equals 0. I don't need to do it again. It's the exact same. And then I'm going to take 20 minus 2X and set it equal to 0. So I'm going to start by subtracting 20 to the opposite side. Negative 2X equals 0 minus 20 is negative 20. Dividing by negative 2, and we can see that X has to be greater than 0, and X has to be negative 20 divided by negative 2 has to be less than 10. Now, how else could we? Okay, so we are supposed to understand how to do this algebraically. I've just shown you how to do that. I did plug in this equation that is able to express the volume of the function in terms of X. I plugged this in. I have graphed it, and I do want to show you that we have a value of 0. We can see it's a solution, and a value at 10 is also a solution. So X has to be greater than 0 and less than 10. Okay, so we have identified the domain, and I can write this correctly, greater than 0, less than 10. Find the volume of the object when the width, so this is our width, is 5. So when X equals 5, X equals 5. One way would be to plug 5 in here and to solve. Other ways we can go second trace value, typing in 5, and we can see the value, or that the volume is 250. 250, we're talking about feet cubed, because again, I could also come up here, and knowing that we have a width of 5, I get the other way to do it would have been 5 times 5 times 20, subtract, 2 times 5 is 10, and we can still see that we're able to achieve 250 feet cubed. Again, cubed because it is volume, not area. Find the maximum. So I have my picture. Let's find the maximum. Second trace maximum, somewhere to the left, somewhere to the right, and now we're guessing. Okay, so keep in mind, you can see our numbers down below. So our maximum volume is 296.5, I'm going to round here, 0.3 feet cubed. Okay, so we're going to keep this right here, and now we want to know what is the dimensions if the volume, what would be the dimensions of the object if the volume is 250. That's going to be my next thing. What if it's 250? So if I know the volume, remember volume is going to be my Y value. That's my output. X is going to be the width. Volume is going to be the output when I look at this equation. This is the equation I've plugged in. Some may say, well, isn't your height your Y value? This is the equation. So X is my width, and what I produce for a Y is my volume. So it's saying if the volume is 250. So I switch this to 250 in a graph, and I want to know where does it intersect. Okay, so right now I don't need to have Y values that are in the negative. Remember, my Y values are going to show what the volume is. So there's no need. So I'm going to come up here and I'm going to take out negative y values. It'll just be a better, oops, sorry, I did the wrong number here. No, I did the wrong one. My maximum should have been 3,000 or 2,900. The minimum should have been 0. Okay, I think we can even zoom that in a little bit better. I think we can zoom that in a little bit better. Let's see what this looks like. So 0, that looks a little too big. Let's go 2,000 and see if that's better. Nope. Let's go up to 500 and see if this is better. Perfect, 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 perfect. Okay, so now I have a nice view of this, and I have gone up here to where y equals 250 because it says, hey, when the volume's 250, what could be the dimensions? And I see that it intersects in 2 places. So second trace, intersect. Let's look at those options. Enter, enter, enter. Okay, so one time x could be 5. So the dimensions here, length times width times height, length times width times height, could be 5 by 5, so 5 by 5, and I was able to achieve that from this x value. Now how do I figure out the height? We're going to come back up here. So if x is 5, 2 times 5 is 10, 20 minus 10 is 10. So 5 times 5 times 20, that's one option. Let's look at another option. Second trace, intersect, enter, enter, enter. Another option is 8.09. Okay, so 8.09 times 0.09 times, now I need to figure out what the height is. So I do the exact same thing. I'm going to take 20, subtract 2 times 8.09, and I get an answer of 3.82. So I have 2 different options.